A hole in the ground beside the sea is a hole the sea is already trying to fill. But in Dubai Marina, the men who dig the deepest holes work a short walk from salt water, and those holes stay dry for years. Somebody pays for that, 7 days a week. Here is how that works. A concrete wall goes into the ground first. Then the sand comes out. Then steel anchors bolt that wall into the damp earth behind it. At Cayan Tower, they dug down 72 feet. At first, this might just seem like ordinary construction. The boring part, before a building starts. On a Wednesday morning in February, in the year 2007, that wall gave way. Nearly 100 Arabtec men were standing at the bottom of that hole. The men smelled wet sand before anybody saw anything. Under their boots, the ground went soft, and the air down in the pit turned cold. So, here are 2 questions for you. How fast does a wall like that fail in Dubai Marina once it has started? And why is the tower standing on that spot today, famous for a shape 800 feet above the ground? You have walked past a construction hoarding and heard the ground working behind it. The noise of ground moving has an ordinary version, and it also has a version that men run from. Here is what the supervisors at Cayan Tower saw first. A slight movement in the wall. Then, cracks. They ordered every man out of the hole. According to the engineers who later investigated the failure, the diaphragm wall crumbled within 2 minutes of those cracks being noticed. The excavation was completely flooded within 4 minutes. One worker described a sharp and loud sound. Then, he said, sand poured down the sides. Nobody was killed at Cayan Tower that morning. Say that first. It stays true all the way through. The bill for those 4 minutes has been put at around 100 million dirhams by one account, and at close to 200 million dirhams by another. Hold on to both of those numbers, because you will need them later. Neither figure was paid by the men who climbed out of that pit. The building that eventually rose out of that flooded hole is Cayan Tower, in Dubai Marina, 1,005 feet tall, 73 floors above ground, and 5 below it. Between the pavement and the roof, Cayan Tower turns through 90 degrees. Photographers love the shape. Almost nobody mentions the 4 minutes. To understand Cayan Tower, you have to stop looking at the twist and start looking at the ground. Dubai Marina is not old coastline. Dubai Marina is a channel cut into the desert and filled with seawater, and the land beside it was placed there by dredgers. Engineers call that reclaimed ground. Reclaimed sand under your feet has a delivery date. Every deep basement in Dubai Marina meets the same problem. The water table sits high, the sea sits close, and the moment a crane digs a hole, that hole becomes the lowest point for a very long way in every direction. The tool for the job in Dubai Marina is a diaphragm wall. Some engineers call it a slurry wall. A narrow trench gets cut, heavy fluid holds the sides open, and concrete goes in from the bottom up. The fluid gets pushed out. What is left behind is a concrete wall that was built underground before anybody dug anything. What follows is that system taken apart, one piece at a time. This channel exists to take apart systems like this one, so if that is what you came for, subscribe and stay with it. Then the digging starts inside it. An Arabtec crew works down in stages. As the floor of the pit drops, that wall has to be tied back. Steel anchors run out through the wall and into the soil behind it, and each one gets tensioned like a very large bolt. At the corners, bracing goes in. Every foot the Arabtec crew digs, the pressure on that Dubai Marina wall climbs, and the cost climbs with it. The contractor pays for every extra anchor before the first floor slab exists. At Cayan Tower, the pit reached about 72 feet, 5 basement levels. On one side of that wall sat the seawater of Dubai Marina, the whole time. Now the people. Ross Weimer was a design partner at Skidmore, Owings Merrill, the firm that designed Cayan Tower. Weimer described how the tower gets built in one sentence. It is as if you were building a layer cake. Here is what a layer cake means for the man running the formwork crew in Dubai. The foreman stands on a slab that was poured a few days earlier and is still warm. Above him hangs an aluminium mold in the shape of one floor. When the concrete has cured enough to carry itself, that mold gets lifted. Before it is set down again, the crew rotates it by 1.2 degrees. Not 1.2 degrees measured from the ground. 1.2 degrees from the floor directly underneath. Then they pour. Then they lift. Then they rotate again. Do that 75 times, and the tower has turned through 90 degrees. Every one of those cycles is a day the developer pays for and does not sell. The crew never sees a twist. The crew sees one mold, bought once, and used 75 times. In a Gulf summer, that deck is open to the sun with nothing above it. Bare concrete gets far hotter than a bare hand can hold, which is why the shift starts before sunrise. The wind comes up in the afternoon, and the mold starts to move on its lines. Dust gets into everything, including the threads on the bolts. A surveyor checks the angle before every pour. A bad pour is a floor somebody pays to break out. The European standard for ground anchors, numbered 1537, sets out how a contractor proves an anchor will hold before anybody stands under it. The American Concrete Institute publishes the code that governs structural concrete in buildings, numbered 318. Code 318 tells an engineer what a column can carry. The code does not tell anybody what the sand behind a wall is going to do on a Wednesday. Now the engineer who set the goal. William Baker is the structural engineering partner at Skidmore, Owings Merrill. Baker is also the engineer behind Burj Khalifa. Baker put the goal for Cayan Tower plainly. Baker said the challenge was to distill a complex design idea into a simple structural solution, using simple construction technology. That one sentence is the whole building. The twist at Cayan Tower is not a structural feat. The twist is one ordinary floor, rotated 75 times. Remember the core. Inside Cayan Tower runs a concrete cylinder carrying the lifts and the services. The core cylinder stands perfectly vertical from the raft to the roof, and it does not rotate at all. The floors turn around it, the way slices turn around a spine. The columns on the outside are what lean. Each was priced as a standard column. Stand in front of Cayan Tower, and they read as vertical. Walk around the corner, and the same columns are tilted by as much as 10 degrees. So that is the shape, a stacking trick, done with one mold and a surveyor. Which leaves the harder question. If the tower above the pavement was the simple part, what happened below it? Back to the whole. The construction contract for Cayan Tower was signed in November, in the year 2006, at around 700 million dirhams. 3 months later, the wall failed. The men got out. The pit did not. Divers went down into the flooded pit, paid by the day. Arabtec said the incident was under investigation. Here is the part most retellings skip. No official finding on the cause was ever published. I went looking for one. I could not find it. If a public report exists and you know where it is, put the link in the comments and I will pin it. A missing report is common. The hole in the record is still a hole, and somebody still paid to fill the real one. The repair work went to a structural engineer named William Walton, a vice president at GEI Consultants in Chicago. Walton was not there to build a tower. Walton was there to design shoring that would let the excavation be restored, in ground that had just demonstrated exactly what it does when the restraint goes. Think about the sequence William Walton was handed at Cayan Tower, a pit 72 feet deep, full of seawater and collapsed sand, a damaged diaphragm wall on the Dubai Marina side, and one rule that cannot be broken. You cannot pump the water out first. Drop the level inside the pit before the wall is restored, and you have taken away the only thing balancing the pressure pushing in from outside. The water in the hole is doing the job the anchors used to do. So the work at Cayan Tower ran in what feels to you like the wrong order. Stabilize, then dewater, then inspect, then rebuild. By the middle of that year, the remedial works on the basement walls had been carried out, and the excavation was described as ready for the remaining water to be pumped out. Eurocode 7, the European standard for geotechnical design, sets out how an engineer demonstrates that a retaining structure will hold. Applying Eurocode 7 to a drawing is one exercise. Applying it to a wall that has already failed once is a very different one, because now the ground has a history and everybody knows what that history is. Then somebody has to pay for all of it. Here the public record splits, and it splits badly. One published account puts the cost of the Cayan Tower incident at around 100 million dirhams, roughly $27 million. Another account, quoting the chief executive of the developer, puts it near 200 million dirhams. That is not a rounding difference. The second figure is double the first. Both numbers come from mainstream reporting. Neither figure has been reconciled by the developer or the contractor. So when a figure for this incident turns up somewhere, it is worth asking which of the two it came from. The developer was Cayan Group. Karim Durbas, the chief executive at Cayan, described the effect in flat commercial language. Durbas said the collapse had a big impact on the project schedule. Those are 11 flat words, with a great deal of money folded up inside them. Now, the tower itself, which carries 3 different price tags. The first is 700 million dirhams for the construction contract. The second is 850 million dirhams, described as an expected final cost. The third is 1 billion dirhams, described as the total project cost at opening. You are looking at 3 answers to one question. Some of that spread is scope, because a contract is not a project. But 2 of those figures answer the same question in different years, and only one of them can be right. Nobody at Cayan or Arabtec has ever squared them in public. Work on the site in Dubai Marina stopped, and the cranes stood still for a long time. Accounts of how long differ, from about a year to around 18 months. The crew did not come back to Dubai Marina until 2008, and then the market fell out from under the whole thing. Dubai property prices dropped by more than half from the peak at the end of 2008. Cayan Tower had been sold off plan. Buyers had already paid for apartments in a building that was supposed to hand over years earlier. Handover slipped to December 2011, then slipped again to October 2012. By March 2012, the tower stood at about 80% complete. Omar Derbas, a senior project manager at Cayan, put it the way people do when a thing has finally survived. Derbas said they had proved everybody wrong, that they were still there, and that the building was almost ready. Cayan Tower opened on the 10th of June, 2013, with fireworks and light thrown across the facade. 495 apartments. Around 80% of them had sold by opening day. So who carried that delay? Not the wall, and not the engineers. The buyers carried the years. Cayan Group carried the interest. Arabtec carried a crew standing still on a site in Dubai Marina with nothing to pour. Now the skin, because the same idea runs all the way through it. A twisting tower sounds like a facade nightmare. If every floor is rotated, surely every panel has to be a different shape. The assumption is wrong, and the reason it is wrong is the most useful thing in the whole building. The metal panels on the Cayan Tower facade in Dubai Marina are standardized rectangles, roughly 82 inches by 124 inches. The same part, ordered over and over again. In front of the glass sit screen panels, 1 story high, painted silver, standing about 4 inches clear of the glass. The screens come in 2 widths, The panels are between 30 and 60% open, so the sun gets cut without the view being closed off. The twist on Cayan Tower comes from where those identical parts are placed. Turn a stack of identical rectangles a degree at a time, and the eye reads a spiral. The factory reads a repeat order. So that is the trick. The repeat order pays for itself twice. The tower is cheaper to build. The facade is also cheaper to repair, because a cracked panel on floor 60 has a twin sitting on floor 12. The firm Lurch Bates was brought in by Cayan Group as facade maintenance consultant on Cayan Tower. Facade access is a job almost nobody thinks about. Somebody has to work out how a cleaning cradle reaches a surface that rotates as it rises, in a city where the afternoon wind comes up hard and the dust never really stops. I could not find a published description of the final access system at Cayan Tower. What is documented is that the problem went to a specialist firm early, and that is itself a decision. Somebody chose to pay a consultant in 2007 so that a cleaning crew would have a route in 2013. The wind got the same treatment. The wind consultant was the Alan G. Davenport Wind Engineering Group, a laboratory named after the man who effectively invented modern wind engineering for tall buildings. Cayan Tower was tested in a wind tunnel. Somebody paid for that tunnel time before a column was poured. Here is the mechanism, and it is easy to get wrong. A tall building standing in steady windsheds vortices. Air peels off one side, then off the other, in a rhythm you could count. If that rhythm lines up along the height of the tower, it pushes the whole building sideways in time with itself. A twisted shape breaks the rhythm. Baker described it as confusing the wind so that the forces cannot organize themselves. Every level of Cayan Tower presents a slightly different face to the same gust, and the shedding never gets to agree with itself. Shape is free. A damper is not cheap. One warning before we go on. Figures circulate claiming a specific percentage reduction in wind load for Cayan Tower compared with a straight tower. I could not verify any of them in a primary source, so I am not going to hand you one. The mechanism is well documented. The number is not. Now the people who live in Cayan Tower today, the residents of those 495 apartments in Dubai Marina, pay a service charge, and part of that charge buys the cradle, the panels, and the crew who go out on the face. Cayan Tower is not a normal building for a maintenance crew to work on. Every access position is a slightly different angle from the one below it. The bill for that arrives every year, forever, and you pay it if you hold the keys. Skidmore, Owings, and Merrill designed the shape. The owners in Dubai Marina inherited the upkeep. What follows is a hypothetical engineering stress test. It is not a description or a prediction of an actual event at any specific tower in Dubai Marina. Put the clock back to February 2007 and change 4 things. The cracks appear at 2 in the morning instead of during a day shift, so the men who spot them are fewer and more tired. A shamal is blowing in off the Gulf, so the water in Dubai Marina is already moving hard against the diaphragm wall. A pump is down for maintenance, so the level inside the pit sits higher than it should, and the anchors on the marina side were installed through fill that was placed late in the reclamation. The Cayan Tower wall does exactly what it did before. It cracks. It crumbles. Except now the 4 minutes start in the dark. So the questions stack up. How many men climb 72 feet of scaffold in 4 minutes? Who calls the evacuation, and how certain does that person have to be before he calls it? If a supervisor waits 90 seconds to be sure, what has he just spent? And once the pit is full of seawater, how does anybody tell a wall that failed from a wall that was overloaded by something nobody wrote down? None of those questions has a clean answer for you, or for anybody else. Asking them out loud is the whole point, because the answers are what a developer ends up paying for. Asking them out loud is the whole point. The real morning at Cayan Tower had daylight, a full crew, and supervisors who called it early. Daylight, a full crew, and an early call are not engineering. All three are luck and habit, and they are the reason this is a story about a delay instead of a story about a funeral. Now the record. When Cayan Tower opened, it took the twisted tower record from Turning Torso in Sweden. Cayan Tower held that record until Shanghai Tower took it in February 2015. The record is the sentence Cayan Tower gets remembered by, and it is the wrong sentence. The twist was solved with one aluminium mold, a surveyor, and a small angle turned 75 times. Cheap in ideas, cheap in parts. The hard problem was a concrete wall in wet sand, holding back a marina, with 100 men standing on the wrong side of it. The wall problem got solved twice, at Cayan Tower. Once badly, before February 2007. Once properly, by a shoring design that nobody photographs. Every tall building in a reclaimed district in Dubai is standing on that second solution, and somebody paid an engineer to draw it. The tower is the part that gets looked at. The wall is the part that decides whether there is a tower at all. The failure mechanisms here are general principles of deep excavation in reclaimed ground. Conditions vary by site. Nothing here asserts that any named building is unsafe today. The stress test is hypothetical. Footage is illustrative stock. If you want to understand the hidden systems that keep enormous cities standing, subscribe to the channel. And a question for you. Have you ever been on a site where somebody called an evacuation and turned out to be right? Tell us what you noticed first, in the comments below.